I've broken one of the most important rules for mechanics. No boats and no RVs. It's a Ford. It's 1994. It's an E350 chassis. It's got all the access problems of a van, all the wiring problems of a plow truck. Plus there's a giant wooden box on the back that you can poop in. Yeah. Let's get to it. It's got a slight identity crisis, but otherwise pretty clean. I think it's only got 27,000 miles or something like that. So 460 gas engine under the hood. And the problem is, he said it runs pretty good when it's cold, but as it warms up, it starts to kind of run rough. And he said eventually the engine will actually die while it's sitting there idling. It's got the insufferable Ford door dinger and the cursory big block exhaust manifold leaks. So that's the issue. It runs rough and then it kind of gets worse as it warms up. Being a 94, this is OBD1. So there's our diagnostic connector right there. The only scan tool I have that really works with OBD1 is the old Snap-on Solus. We have to have some adapters. So we need this Ford, that one down there, and then we're going to need this thing that adapts my old school connectors to this OBD2 cable, and then we're also going to need this 12-volt power supply cable, which has a cigar lighter end on it. So we're also going to need this cigar lighter adapter. Okay, it says we need the 1A or 1B adapter with the DA5 cable adapter. We've got the 1B with the DA5, so we're all set. And we'll go to the codes menu. These Fords, they just kind of suck. They have fast codes and slow codes and key on, engine off, key on, engine running. So it's doing a self-test, I guess. Oh boy, no faults present. It's pretty hopeful. Let's see if we have data. Yes, okay. This is great. So before we had live data, on the scan tool, the only way to see the value of, any of the sensors and stuff was to install these crazy breakout boxes between the connectors and the PCM, and then read the voltages with a voltmeter. It was not handy at all. All right, let's see if we can identify anything that's kind of out of the ordinary. Look at the O2 sensor. It's basically stuck low. For just a second there, we had a little blip. Yeah, right there. So it tried to go into closed loop. Fuel trim's like 11%. I don't know if that works when it's still in open loop. So that looks like the problem to me. Just the O2 sensor is just dead. I'm pretty sure we got a bad O2 sensor, this thing. But I want to be sure before we fully commit to the parts canon. These things are basically magic. And the problem with magic is that it's very hard to understand and it's very unreliable. It's actually amazing that these things work at all. What I think is happening is the O2 sensor is under-reporting.
So it's saying that the engine is lean when it's not, and when it tries to go into closed loop, it just starts pouring fuel into the injectors, and it spikes way up, and then the computer says that's not right, and it goes back to open loop. We can test the heater circuit, so we'll just put a test light from positive to negative and see if we have current here in the heater. We can also test the signal ground. We'll just put 12 volt power to this wire here. If the test light lights, we've got a good ground. Then we can put that same 12 volt power to the signal pin, and we can watch our scan tool. And if the voltage on the scan tool goes high, then we know we have good wiring for the positive side of the signal. We can do the same thing with a test light to ground and pull this down to 0. If the voltage goes down to 0, then we've got good, circuit integrity, and chances are we just have a bad sensor. Keep an eye on the O2 sensor voltage. It's coming down, which probably means the heater is working, but we're going to find out. I'm going under with the test light. Okay. Good. Good. Okay, so I've got 2 good grounds, and I was able to pull that down to 0.
So this time it's actually totally different. The O2 sensor is stuck high. It's like over 800 millivolts. It was only like 100 millivolts the last time. So I have no idea what's going on. What just happened? It just went from high to low. I don't get it. Now it's stuck high again.
All right. I mean, it was stuck high. The O2 sensor was stuck high. Then it was stuck low. But it didn't seem to really make any difference on the fuel trim. It was in closed loop. Then it was in open loop. Didn't really seem to make any difference. Sometimes it responded to an artificial rich condition. Sometimes it didn't.
This is interesting. It shows 6.65 volts on the 5 volt reference. But it's actually 5.
Max, can't you just tell me what the problem is? Be a lot easier. Good morning. It's the following day. We're going to kind of forget about yesterday. Everything I thought was a problem was not a problem, and I have no idea what the problem is. The big problem is I'm a terrible businessman. 95% of shops, they would have said no as soon as they found out it was an RV. The other 5% of shops, they would have worked on it for about 45 minutes, maybe thrown some parts at it. And when it didn't solve the problem, they would have called the customer and said, hey, pay us for an hour of labor, take your RV home, and they would have washed their hands of it. But for some reason, I can't do that. When there's a problem like this that I can't solve, it gets stuck in my craw, and I have to figure it out. And when I do figure it out, it makes me happy, but it typically doesn't make me money. So there's your macroeconomics lesson for the day. Anyway, we're going to see if we can get to the bottom of it. I've got some ideas. I don't know if I've ever seen anything quite like this before. It's been a while since I made one of my trademark drawings. Let's talk about the problem, and we'll go through some of my various theories, and I think you're going to see that none of these are correct. So the problem is the engine runs rough, especially at idle, and it has kind of a popping, almost a misfire sound in the exhaust, and the engine kind of drops out and then it recovers and it just kind of drifts around. It is not running right. He said it'll actually die. I haven't experienced that, but I don't doubt him. My first kind of fixation was on the O2 sensor. It seemed to be stuck low, which I thought was making the engine run rich and keeping it in open loop. So when the engine starts and it's cold, it works in open loop. It uses the air temperature, the manifold pressure, the coolant temperature, the throttle position, RPM, various sensors, and then it uses known values to guess how much fuel to inject to get the engine running. The coolant temperature sensor is kind of like your choke. When the engine's cold, it needs more fuel. As it warms up, it leans out. And then eventually, maybe after 3 or 4 minutes, the O2 sensors are warm. They start working, and then that's the primary feedback to the computer, and it should go into closed loop. The reason that it's switching high to low like this and staying there is because this engine has secondary air injection, which I forgot about. So there's actually a pump, belt drive off the front of the engine, that pumps air into the exhaust. And when it turns on, it's blowing oxygen past the O2 sensor, so the O2 sensor goes high. When it turns off, it goes back low. Now, I'm not sure why when it turns off, it doesn't go to 500 millivolts. It seems to stick down around 100 millivolts. I'm not going to worry too much about that. I think the O2 sensor is working, and it seems to be working correctly. So my next theory was that it just had a misfire. So I took my fancy little pliers here, and I popped each spark plug wire off. And they're all contributing. So I don't think it's a misfire. At least it's not a dead miss. So then I thought maybe it had a vacuum leak. But this is a speed density engine, so it uses a MAP sensor. It does not have a mass airflow sensor. And generally speaking, vacuum leaks don't really affect speed density engines. They'll make the idle a little bit high, but they won't affect the air-fuel ratio. The only thing that I can see that's left that seems weird to me is that the 5-volt reference on the scan tool shows like 6.63 volts. And I measured it at the MAP sensor with a multimeter, and it's right on 5 volts. So I don't know why the scan tool value is different from what we're seeing at the sensor. Also, the timing advance, it seems to drift back and forth between 24 and 32 degrees, and it just sharply switches back and forth. Now, in my research, I learned that on these old Fords, the idle control depends on 2 things. The primary control is the IAC, the idle air control solenoid. It's actually a valve in the intake that opens and controls the idle RPM. The throttle stays closed, the valve opens, and if you have a load like the AC compressor comes on, the valve opens more and maintains your RPM. That, I believe, is working. But apparently it also uses the timing advance to control the idle, to make small adjustments. So this is kind of like your coarse adjustment, and this is your fine adjustment. And it's supposed to move the timing advance to keep the idle steady. And if it's jumping from 24 to 32, I wonder if that could be the cause of our problem. It does almost act like the timing is off. So I don't know how to test that. I wonder if this has a spout connector. If we could take the spout connector off, I think that disables the timing advance. We could see if it runs better. I'm going to have to research that, but that's kind of the only thing I've got to go on right now. These 3 things have been a dead end. Yeah, like I said, I've never seen anything quite like this.
Well, it definitely runs different.
Do I hear a straight pipe bowl hauler? Peterbilt could knock me over with a feather. Anyway, it seems to run differently with the spout connector unplugged. So that means that the computer must be controlling the timing. So spout stands for spark output, I believe. And when you remove this little connector, it basically stops the computer from being able to advance the timing, and it puts you at your base timing. So when you set the timing, you remove the spout connector. But the timing advance is completely controlled by the computer. The pickup is in the distributor. It goes through the ignition module, which is over here, goes back to the computer. The computer reads it, deciphers it, translates it, advances it, and sends it back through the spout connector to the ignition module, which actually fires the coil. So if it can't control the ignition timing, does that mean we have a computer issue? A PCM issue? Kind of looks that way. I also don't like that VREF being 6.63 or whatever volts. I feel like it should be 5 volts, unless that means something other than what I think it does. I don't know. The computer's buried back here in the firewall. I'm going to pull it out. We're going to take a look at it. Something we're missing. Uh-oh. Uh-oh. I think I see a problem. Yep. That'll do it. I wonder if that filter cap is on the 5-volt reference circuit. I wouldn't be surprised if it is. So that's an electrolytic capacitor, and the electrolyte has leaked out and it rotted off one of the legs of the capacitor. That's got to be the problem, or a problem. Let's see if we can fix that. So that is a 16 volt 47 microfarad. So it looks like I've got some 47s. 25 volts, that'll work. And then the other two are, well, let's see. The other one is 63 volts, 10 microfarads. That might be a problem. Let's see. 100 volts. That'd probably do it. Okay. Now what are these? 50 volts. Well, shouldn't hurt to go higher voltage, so 100 volts will work. Cool. Pays to be a hoarder. Alright, I made a little map of the capacitors with the negative side marked. So we're going to go ahead and try to desolder these components. Everybody always hates the way I do this, and they would hate the way that I pronounce solder. So I'm just going to do it the way I feel like it, and I will deal with the consequences down in the comment section. A kindly viewer sent me some new wick and some suckers and a soldering iron, which I have used. It seems to work pretty well, but I like my old Weller. It's a Wes D51 kind of benchtop soldering iron, and I've got this fancy little gizmo to clean the tips, and then to desolder, I like this old Heiko 808 pump. This thing is great. It gets hot here, it sucks here, does a pretty good job. I built this fancy stand for it. I think kind of the big problem is we've got this conformal coating on the board, so it's this sticky, nasty stuff that they spray onto them. It's supposed to protect them from moisture, but it makes it really hard to do anything with them. So we're gonna get some flux, and we'll try adding some solder first. See if that kind of helps us. So we've got to get the legs bent back up. And we've got to do it without disrupting any of these tiny surface mount components next to it. That's cleaned up about as good as it's gonna get. So it peeled the solder mask off here. The electrolyte did, but I think we're still good. So that must be the ground side. Kind of same deal over here, ground side. But this one right here, pretty messy. So the good news is the plated through holes are still there, and I don't think there's any connection on the top side on that one. It's all on the bottom side. So we're gonna jam them in there. We'll see what happens. So that's the 10 microfarad, and then 47. Just double check. 47, 47, 10, and all the negative sides should face that way. A little bit of flux. All right. I think that's pretty good.
There. I feel like it's either going to work or it's going to explode spectacularly. I think we got it. Not the way I expected, but I think we got it. So our idle now is pretty much rock solid. Right around 800. So the O2 sensor's all the way lean. But if I cover up the intake for the secondary air, you should see that come up. I think. There it goes. Anyway, it's working. Our IAC percentage is a little lower. It was around 65%. Our spark advance is lower. Well, pretty much. Stays around 25. I don't know why this VREF is still 6.65, but I'm not going to look a gift horse in the mouth. I think it's good.
I'm going to go ahead and put this air box back in. Oh. I'm trying to figure out how I can possibly edit this video to make it make sense. Because, I mean, I was here and I did it and it doesn't make sense to me. So I don't know what we're gonna do. I mean, I guess it's a win. It runs fine now. So obviously that electrolytic capacitor was the problem. But I have a lot of questions and not any answers. I don't understand the O2 sensor. I don't really understand how that works at all. Like, how does the computer ever know whether it's rich or lean if it's using the secondary air injection system to just blast air right past that O2 sensor? I don't understand why it idles in open loop. I've seen other vehicles like that. Usually it's because the O2 sensor doesn't stay hot enough that it drops back into open loop. This one doesn't seem to ever even try to go into closed loop. So not sure what the criteria are for that. I don't understand that VREF, why it was at 6.63 volts, what the VREF even means. We measured it at 5 volts at the map sensor, and that was before I even messed with the computer. So obviously the capacitor didn't have anything to do with that. I don't know, I still don't really understand that timing advance to correct the idle. That seems like a really weird thing to do. But yeah, I guess we're gonna move on. So don't feel bad if you didn't follow this one or you got kind of lost. I'm right there with you. Thanks for watching. It's fixed. Must be a lot of fun to drive one of these in a strong crosswind. You can see my trash can went for a ride. They farmed this field last year. Not this year.
Wait a minute, no, don't go out there, you'll be in up to your neck.
Can't resist, can you? Go! It's fine, the wind's gonna blow it back.
It's coming!
Don't get in the water.
Keep going! Keep going! A little bit more!
Right over the dead coon.
That was our number one fan. That's normally a nice tame creek. Not today. diver duck.
I think today I